All right, to figure out the moon's rising position or setting position, we have to do the same thing we did with the sun. Remember, we use this equation. Theta equals the inverse cosine of 0.01454 sine of your latitude plus the sine of the declination. And then you divide all that by the 0.99989 times the cosine of the latitude. Okay, so we're going to use the same equation because this is the same one. Remember, this only ever gives us the rising position. Okay, but the key is we got to figure out what the declination is. So for a given day of the year, you have to look up what the declination of the sun is. So for example, let me do a problem here to show you how we do it. So let's pick a day. I'm going to pick, let's do April 20th. Okay, on April 20th, I look up and the sun's declination is 11 degrees 19 minutes. Okay, so then I'm going to convert that into degrees and minutes. So I'm going to take 19 divided by 60 and add that to 11. And I get that this is equal to 11.317 degrees. All right, so this is the declination of the sun. Now when we want to find the rising or setting the position, we have to, the problem will tell you the moon is at the northern extreme or its maximum positive declination. That would be the northern extreme. So it's either at maximum positive declination, which would mean I would add 5 to the sun. Or if I said maximum north, you would also add 5. If you said maximum southern, or maximum south declination, or minimum, or yeah, I think that's the way I really do it, or maximum negative declination, you would subtract 5 from the sun. So in this case, we're going to do it for a latitude of, excuse me, let's say 48 degrees north. So at 48 degrees north, we want to find out both. Find both extreme rising positions. Extreme rising positions of the moon. Okay, so I have my latitude. The latitude is going to be 48 degrees. My declination is going to be equal to, well, I want to do it twice. I want to do it with the sun, 11.317, plus 5 degrees. This would be the northern declination. And the southern extreme would be 11.317 minus 5 degrees. So I just determine what those are, plus 5. And I get this is 16.317 degrees. And here I get 6.317 degrees. These should always be exactly 10 degrees apart because here you're adding 5, here you're subtracting 5. Then I plug these declinations and the latitude back into this equation. And this is what I'm going to get. So for the northern one, this is my value I'm going to get. So I go to I'm going to use my programmed calculator, put in a latitude of 48 and a declination of 16.317, and I get 64 degrees, 64.1 degrees. For the southern position, I get the value of 48 for the latitude, 6.317. And I get 79.6 degrees. All right, but remember, for these kind of problems, I always want you to draw a picture. So you're going to draw one of these. It's an azimuth picture. So this is north, east, west, south. I'm going to draw the lines across here. Remember, this is 0 degrees, 90, 180. Since we're only doing with the rising position, we're only going to worry about this side over here. Well, 64 is right here. So if this is 90, 64 is about here. So that this angle is 64 degrees, 64.1 degrees. And then the other one up here is at 79.6 degrees. So this is for April 20th. For April 20th, this is Moon's northern extreme rising position. I know that's complicated, but that's the way it is. This would be for April 20th, Moon's southern extreme rising position. All right. That's how you do these problems. Now, if I had asked for setting position, you would do like you did before, and you would subtract it from 360 and put it over here on the western side. Those values would go this way, but you would always measure your azimuth going the other way. Same exact thing we did for the sun. So the only tricky part here is to remember that the declination that you put into this program has to be the declination of the sun plus or minus the declination of the moon, depending on what extreme you want. All right, what if we went the other way around? Remember, we also had this equation where we said, so this is a different type problem here, declination is equal to the inverse sine of 0.99989 cosine the latitude times the cosine of the azimuth minus 0.01454 sine of the latitude. All right, what if I gave you the position and I said, oh, the moon is rising here. Rises at a certain angle and at, for a certain latitude. Then you work backwards and you get the declination, but the tricky part is this. So if I give you this, so let me do this as an example here. Let's say I say the moon is rising at a declination of, let's just put something here, 85 degrees, and we're going to use the same latitude of 48 degrees. Okay, and I want to know what days of the year, what day of the year, or days of the year, the moon will rise at this position if it is at its southern extreme. Okay, so what I do is I take these numbers here and I plug it into the declination equation. So when I plug that into my equation, I get that 40 latitude 48 and theta is 85. I get the declination, oh, and I picked a tricky one, is equal to 2.72 degrees. All right, but that's the declination of the moon. Of the moon, yeah, declination of the moon. But when we want to find out what day of the year, we have to go back to our chart, this chart, but this doesn't have declination of the moon, this has declination of the sun, so I got to figure out what the declination of the sun is. So in this case, the moon is at its southern extreme, okay? So that means when it was southern, I subtracted 5 from the sun. So to figure out where the sun is, I have to go back, I do have to do the opposite. So I'm going to add 5 degrees to the sun, so the sun is going to be, so this is the moon's declination. The sun's declination is going to be 2.7 plus 5, or 7.7 degrees. All right, the key is this. When it's southern extreme, I do the opposite. I add 5. And if it was northern extreme, I would subtract 5 from whatever declination I've got of the moon. Because you're working the problem backwards. Okay? And then I look up 7.7 degrees on my chart here, and I say 7.7. Oh, that's going to be close to April 10th. Let's call it April 11th. And the other position would be over here. Would be about 7.7 would be about September 3rd. And those are from the sun's declination right there. Okay? That's how you do azimuth position for the moon. Again, same thing, just remember you work off the declination of the sun and you add or subtract 5 degrees from that, and then you plug it into the same equations you had before. The good news is, this is the last math you'll have to do for the class, is figuring out the moon's position.